looking over the other stuff, we set up a model of the physical world where we've got our terrain elevation data and clutter and all that stuff, and we're set up with propagation models appropriate to this frequency band, and also to the fact that our AMI meter may be on the side of a house. If I'm setting up from scratch, what I can do first is define different types of meshing equipment. And we call them meters. This can be an electric meter on a home or inside the building if we apply some additional losses to it or what have you. And you notice we also support water and gas meters, which can have some different connectivity rules. Data symbols here. I'm going to turn on my vulnerable meters. So this orange diamond that I've set up, that means a meter that does not have full hopping path redundancy. In other words, there's a point of failure somewhere in its hopping path where if that device went offline, the meter would be disconnected. I want to jump into the gateway view for that gateway. It's located right here in the overall mesh, and you can see the rest of the network up here. But if I want to jump into just the mesh for that one gateway, I can see the graph of that here, and I can pull up my meter placement tool, which this will let me place and add some more redundancy into this, this cluster of meters here. I can move my mouse around and try and find somewhere that I can get another connection back to the gateway. Well, that would be a really good spot for a repeater pole if I, each one of these links here, I just right-clicked on one of my hops. It looks like this is a repeater on the left and then a meter over here on the right. And this is kind of a model of the path between them, and we're showing how much we're grazing through the trees there, which we're accounting some loss for. And the part where people can easily go astray if they're not real experienced with RF planning is that prediction, the rules that it used to come up with that path loss, there's within SignalPro, you can go to databases, towers, and poles and quickly import a list of utility poles or tower assets, including their relative heights and relative cost if that information is available. And from that, based on either multi-point or meshing subscribers, our mesh module can automatically select router locations or gateway locations to serve all of the endpoints in the network. That feature is located in the mesh module under automatically calculate router locations. And I'll look at the capacity planning with mesh awareness. And you can see here that it has produced an overall router solution to serve the endpoints in the network at the level specified using the best case, lowest cost tower solution that our search algorithm could find. And some of our mesh equipment customers have discovered that this gives them a more efficient gateway placement than an ad hoc human design would produce. So in this instance, my gateway number 273 is connecting with through the mesh with many of the endpoints around it, but the red stars represent unconnected mesh devices. I can address this either with the automatic repeater placement tools, which will look at the cost to benefit for each of the towers and place repeaters as needed to try and connect to those devices. Or if I want to use a more hands-on approach, I can go into our router view and place repeater devices by hand using a live path loss calculation for all the potential mesh links. So I'll show my map here. And if I want to see the potential connection, if I place a new repeater in the network, I can choose to place a bridge repeater here. And if I hold down the left mouse click button, it's showing a live evaluation of the hopping potential for a repeater at that location. This can be either totally freehand or constrained to tower locations. If I want to create that repeater, I just go ahead and click the button here, and you can see how the mesh network connectivity has been improved. So in this way, I can quickly go through and improve network connectivity in fringe areas. The topology reporting, which looks at both hopping path redundancy and also gateway redundancy in any mesh network. In the hopping paths here along this sort of rural area, we can see where the devices are able to interconnect with each other fairly well, but there are only a few hopping paths out to the gateway that are possible. This can create constraints in the network called a cut point, where if a device went offline, other downstream devices may be isolated. In this case, the cut node, or what we call a mesh vulnerability, has been identified here with the sideways hourglass symbol that I've selected. And those vulnerable nodes that lack full hopping path redundancy are shown with the orange diamonds here. So the lack of redundancy that we're seeing in this network here could be addressed by placing additional repeaters into the network so that there's always an alternate hopping path. We can also look at gateway redundancy and make sure that there are multiple gateways for each endpoint to be able to hop back to. This is used not only in automatic metering infrastructure, but in mission critical systems such as distribution automation or emergency public safety communication, where we can look at the potential for gateways to interconnect with each other or multi-point end devices to connect back with some other gateway through hopping.